Hi to all the math students out there from Mrs. Marcellus and my good friend Einswine. Einswine's fabulous at working with decimals, and so he's very excited to be here to help us with today's lesson, which is adding and subtracting decimals. Today's learning objective is students will calculate the sum and difference of decimal numbers by applying standard algorithms. Oh, good point, Einswine. Einswine felt that some of you might not know what an algorithm is. An algorithm is just a process or a procedure. So this means we're going to be using standard addition and subtraction. Are you ready to go to the vocabulary and try some examples, Einswine? Okay then, let's proceed. Today's vocabulary: sum, the result of addition; difference, the result of subtraction. When adding and subtracting decimals, you first must line up the decimal points. You do this in order to keep the place values aligned, so you're adding tens to tens and ones to ones and tenths to tenths and so on. Second, you will annex zeros as needed. This means you'll just fill in zeros at different places in the problem to help you keep everything aligned. Then you will add or subtract digits in the same place value position, just as you've learned to do before. Find the sum of 54 and 7/10 and 18 and 2/10. Since it's sum, that means we'll be doing addition. The first thing we want to do is write the problem with the decimal points aligned. So we have 54 and 7/10 plus 18 and 2/10. Then you simply add. So we add up the tenths, bring the decimal straight down in our answer. Then we add the 1 spot, which is 12, so we have to carry the 1. And finally we have an answer of 72 and 9/10. The next problem is to find the sum of 12 and 6 and 38/100. Well, where does the decimal point go when you have a whole number? It comes after the number, or to the right of it. One thing that you might want to try when adding and subtracting decimals, just to help keep everything aligned, is to use graph paper. If it helps you keep everything nice and neat lined up, then by all means that would be a very good strategy. So now we'll go ahead and write the problem, and that would be 12, and we'll add the decimal point there, and then we will add 6 and 38/100, and we have everything lined up. And see how handy the graph paper is? But if we want to annex some zeros, we can simply add them on. Alright, and then we go ahead and add and bring the decimal point straight down. So we have an answer of 18 and 38/100. Next we'll try a subtraction problem. When you're doing subtraction, at least for the problems we're doing right now, the larger value always goes on top. Also, when the problem is written as a subtraction problem with a minus sign in it, for example, if the word "and" was replaced with a minus sign, then the first number in the problem always goes on top and the second number in the problem always goes on the bottom. So we'll rewrite the problem, taking care to line up the decimal points, just as before. That's the most important thing here. We have to line up the decimal points to keep the place values aligned. And then you go ahead and subtract. So 6 minus 1 is 5. And then we run into a little bit of a problem. We're starting with 8, but we need to subtract 9. And we can't just say 8 minus 9 is 1, because that's not true. We'll have to go to the next number to the left, and we'll have to take one away from there and do an exchange. So we're going to take 1/10 away, and we'll turn the 7/10 into 6/10, and we're going to turn that tenth into 10/100. So we'll add it to the 8/100 already there, and now we'll be working with 18. So 18 minus 9 is 9, 6 minus 5 is 1, and 5 minus 3 is 2, and then we bring that decimal point straight down and put it there in our answer. So after we've subtracted, we have 2 and 195 thousandths. Let's try our next problem using the graph paper. We're going to start with a whole number, 8, and then subtract a decimal number from it. As was mentioned before, when you have a whole number, the decimal comes directly to the right of it. Also, the first number in the problem is the one that goes on top. The second number goes on the bottom. We are starting with 8, and we are subtracting 5 and 32 hundredths from 8. So the order that you put them in the problem isn't determined by the length of the number itself. It's determined by the order and the actual value of the number. So we're going to start with 8. So we'll write down 8 and then put the decimal point right after it. And then we're going to subtract 5 and 32 hundredths. Now, some of you might want to bring that 3 and that 2 straight down, but we can't do that because you're actually subtracting from zeros above it. They aren't there, so when you're subtracting, you must annex those zeros before you continue to solve the problem. Let's go ahead and write those zeros in, and then you can clearly see what we're doing here. You're trying to subtract 2 from 0. But if you have 0, you can't take away 2. So we do need to do an exchange. So we'll go over to the 8 and take 1 away and make that 7 and add that on to the number next to it. Well, that's helpful, but it doesn't quite get us to where we need to be. So we again will need to borrow, and we'll add that on to the current position. So now we're in the hundredths position, and now we can subtract 10 minus 2 to get 8. We can subtract 9 minus 3 and can subtract 7 minus 5. The answer is 2 and 68 hundredths. Moving right along to our next subtraction example, we will write down the 17 and 1/10, and then we want to make sure that we line up the decimals. So we'll write the second number underneath it, line up the decimal point, and we're ready to subtract. Again, in this problem, we first must annex some zeros. Once again, we're going to need to borrow. So we go to the first number we can borrow from, which is the 1, and make that a 0, and then move that next door. But that, again, doesn't allow us to subtract 0 minus 7. So we will borrow again, and we'll add that on to the end. Now we can subtract 10 minus 7 is 3. And we'll continue to subtract. And once again, we have a stopping point. So now we're going to have to borrow here, subtract 1 and make it a 6, and add 10 on to that position. So 10 minus 4 is 6, and we can continue subtracting, and 1 minus 1 is 0. So our answer is 4 and 633 thousandths. Hopefully that's what you got too. Next, let's try a couple of word problems. In our first word problem, Herbert is creating a video. The first clip was 23 and 41 hundredths minutes long. The second clip is 18 and 3/10 minutes long. What is the total length of his video? The first thing we need to decide is whether we are adding or subtracting. So you look for key words. The word total is an indicator that we're going to be finding the sum, that we'll be adding the pieces together. We have the first clip added to the second clip to get the total amount of time. We will set up our problem, and we must make sure we line up the decimal points. And as always, you can annex the 0 just to keep everything nice and neat and aligned. And go ahead and do the addition. It is 41 and 71 hundredths, and since it's a word problem, we want to know the total length, which is measured in minutes, so you would put a label of minutes on your answer. In our final problem, Marissa is traveling for work. Before lunch, she drove 178 and 25 hundredths miles. If her GPS indicated at the start of her trip the total distance to her destination is 337 and 8/10 miles, how much farther does she have to travel? So again, we have to figure out, are we trying to find the sum or the difference? Well, in this case, she drove a certain amount of miles, and she still has some left to go. The GPS indicated that the total distance is 337 and 8/10 miles. So that would be everything she travels all together. So far, she has driven 178 and 25/100 miles. So that's just a part of the trip. So we know that the part of the trip she traveled before lunch plus the part of the trip she'll travel after lunch would equal her total distance of 337.8 miles. So basically, we're wanting to find the difference between the total distance and how much she has driven so far. So this is going to be a subtraction problem. We're going to start with the total and subtract how far she's already driven in order to find out how much she has left. We're going to start with 337 and 8/10, and then we will subtract the amount that she drove before lunch. Then we'll annex a 0, and then we're going to have to borrow in order to subtract because we can't take 0 minus 5. So we'll borrow 1 here, and that becomes a 7. We'll add 10 on to 0, and we have 10. Then we'll write that down, and then we'll go ahead and subtract. We'll put our decimal point there. We always bring that straight down. And then we have 7 minus 8. Well, we can't do that, so we're going to have to borrow from the 3 and add 10 onto the 7, which gives us 17. 17 minus 8 is 9. And then we can't subtract 2 minus 7, so we have to borrow once again. And we'll add 10 onto the 2, so now we have 12. 12 minus 7 is 5, and 2 minus 1 is 1. She still has to drive 159 and 55/100 miles. Well, math students, that concludes our lesson on adding and subtracting decimals. And Einstein says, remember, when adding and subtracting decimals, you first must line up the decimals. Bye for now.